In this video, I'm going to be talking about tapers. From the teeny tiniest, smallest tapers used for steam spindles. And this is quite interesting because, normal taper if it's carrying a torque, you need about 2/3 engagement on the taper. But the small spindles used in steam, if you don't get 100% along the length of the taper, it actually doesn't seal. So these teeny tiny tapers for the steam valves are probably the most difficult. Then I'll have a look at doing longer spindles, sort of Morse taper spindles for an arbor for a milling machine. I'll show you how to set that up. And then I'll do a practical example of a very weird taper that's right in the middle of an axle. It's not something you normally run into. And you can't do it with the taper slide because the handle of the taper slide gets in the way and the axle is just too thin. So I'll show you a nice way of doing that. All of these examples and techniques I'm going to show you how to use a standard lathe chuck. So even when I do sort of between centers machining, between the 2 points, I'm still going to use my standard chuck. When I do my very small taper demonstration, I'll do it with the same chuck, and it's a 160 chuck, so it's quite a big chuck for turning very, very small things. And I'm going to show you a very cool hack of getting around using a big chuck to machine very, very small things. And then I'm going to show you how to copy existing tapers. I'm going to show you how to set up tapers, both with the DTI and just using the hand dials on a lathe. If you don't own a DTI, you don't have it. And all sorts of tricks and trades, tricks of the not trade for the home workshop. And yeah, I hope you guys enjoy this video. Let's get cracking. The small taper steam valves are probably the most difficult thing to make because if you don't get a full seal across the full length of the taper, it's just going to leak. So what the trick is, if you make your reamer for your taper spindle and you make all of your taper spindles on exactly the same setup, you're going to get a perfect seal. But I've made a number of locos, so my setup changes and I'm not going to make a reamer every time. So I keep the reamer, and what I do is I machine on the exact same setup. On my first setup, I machine a dummy taper much larger than the reamer. So this gives me a nice surface to dial up my taper slide when I want to make new taper sort of spindles for my steam valves. Now, unfortunately, I can't show you the tiniest sort of taper for my steam spindles because you just can't see it on the video. So this is one of my bigger ones, and it's a little bit easier to see. And it'll be easier to show the setup. Now, the initial setup is actually very, very easy. And all we're trying to do here is just get the setup sort of as close as possible before we do the final adjustments. And one of the easier ways to do that is to just stick a magnet at the end of 2 bars, and they don't really need to be perfect. And what you're trying to do is you're trying to touch the taper at the furthest end and at the closest end. And you're looking for no light coming through. And if you have a look at that, there you go, no light. Now this setup is probably going to be very, very close, but you do need to check it. So let's just check it first with the hand dials, and I'll show you how to do it with the hand dials, and then I'll show you how to do it with a DTI. All right, so let's set up this taper slide using the cross slide dial gauge and the taper slide dial gauge. Now you can use any piece of soft bar stock, but you don't really want to damage the surface. And then it's just a matter of using your dials. Now, do yourself a favor, right? When you do this, just make sure that everything is set on 0 so the taper slide is set on 0 and it's always set on 0 in the same direction. So we're always going to check it on going forward. Now there's a little trick, right? Because your tool post is off center of your taper slide pivot, You can't check that side and then that side and then that side because you're just going to get confused. So what I do is I always check it on the far side and then I drag it along and then I pull it back and I change it always on the far side, because if you change it on the other side, you're going in the wrong direction and you just get confused and it takes longer, right? So let me show you how I do this. It's very, very simple. So what we're going to do is we're just going to touch the dummy tool to the end, and we're just looking for a 0 gap there. Then we zero the dial gauge. Okay. And then you drag your tool all the way to the back and you touch it again. And that there is the amount that you are at. So more or less, you need to move your taper slide to half of that. So this is about 250 microns out. So what we're going to do is we need to go half of that roughly. So we go back. And remember, we need to zero. And we were, now it's back on 0. So remember, we were 250 micron out. So all we need to do now is we actually want to go a little bit away and half of the amount. So we want it to just touch. So it's about there. And now we're going to set this back on 0. And let's see where we are. And look at that, back at 0. So in other words, we have almost 0 play from there to there. And this is as accurate as your dial gauge. So this will cut a pretty decent taper. Now I'm going to show you how to use the DTR, but I'm not going to change anything. So we're going to end up exactly on 0. Then I'll mess it up and I'll show you how to set it using the DTR. All right, so I've put the dial gauge on my taper slide. And one of the things you do need to have a look at with any dial gauge or any method that you're measuring a taper with a point at the end. And I do this with all of my sort of test tapers that I use for setup. And I also do it, actually, interestingly enough, when I make taper reamers, I always leave a pip at the end. And that pip is a very good guide for a number of things. In this case, it makes a fantastic point to line up your dial gauge to the center line of your sort of test taper. All right, let's see how close we were to getting 0. So I'm just touching the dial gauge, and let's move from one side to the other. Oh, okay, I was pretty close. So it is, well, it's half of the increment, so that's 10 micron increments if you can trust the dial to 10 microns. But if we slide it from one side to the other and 20 micron out, yeah, I could live with that. But let me just show you how to set up using a dial gauge. So let me just mess this up a little bit. There we go. So now it's properly messed up. Okay, so it's exactly the same procedure. You zero it on the one side, you drag it to the other side. Oh, now the whole thing has moved. I didn't tighten that bolt enough. All right, well, now it's messed up properly, which is a good thing. Let's just put it close to 0. All right, let's just put it on 0 on this side and see how far out we are. All right, so we are 30 microns out in this direction. So what we want to do now, and remember we're setting it always on this side. So we want to set it to half of that.
So we want to go the other way, 30 microns, roughly half of that. And so that's roughly half of that. And let's zero it on this side. And let's see how close we are. I mean, there we at sort of 10 microns. So if we wipe it across, I mean, that needle is not really moving that much. So from one side to the other, I mean, that's within 10 microns, which is what you're looking for. So when you set up a taper like this, because it's so long, if you sort of within 20 microns from the one side to the other side, you're going to get a good steam fit on a tiny little taper. And the thing is, 20 microns on a taper slide like this, you're really not going to get much better. The best I've gotten on this dial gauge is sort of a 10 micron deviation with the needle sort of consistently. If you want to machine accurate tapers, you need to do it another way, but we'll get to that later on in the video. Let me just give you an example of how to machine one of these small tapers using the setup that I currently have. So let me just tighten up everything, and then I'll machine a small little taper so that you can see how to machine it. Okay, I got to share this with the guys that do the machining, and especially the STEAM model engineering enthusiasts. So our family loves coffee, and we drink our coffee with these Bodems. And these things are one of the few things that just keep on giving. The spindles that I make for my steam valves are made from the stainless steel that they use for the center of these plungers. And it's actually a beautiful stainless steel. It's a free machining stainless steel, and the shaft can be machined down to whatever size that you want. So the shaft is there. That's perfect. And on the other side, this stainless steel gauze that they have at the bottom here is perfect for all of your steam filters. So all of my filters in my tanks or before my injectors are made from this. It's stainless steel. It's a pretty fine filter, and it works really, really well. So top tip, don't throw away these things. They can be used. So if you want to machine a very sort of thin spindle in a larger chuck, you need to hold it properly. And the problem is these chucks generally aren't meant to hold very thin things. So this is actually one of the Bodum spindles. Well, it's going to be a spindle. It was the Bodum sort of center. And what you do is you just machine a piece of bar like this with this size sort of in the middle, and you machine a recess, and then you just slit it with a hacksaw. If you mark your number one chuck in your lathe and you put it back on your number one chuck every time, this is perfect. So even if your chucks are out on your lathe, it doesn't matter, because if you put it back on number one, this will always be perfectly center. And that's how I machine my shafts so accurately with a large chuck. In fact, I don't even use collets anymore with my machine. I just make these things. They take 10 minutes to make, and off you go. So how they work is I have a standard clamp, and it's just a 1/4 inch and 1/4 inch with 2 M3s, and I always machine back 7 mils. And with a single clamp like this, I pretty much do all of my spindles. Then that will go into the chuck, and it gets tightened up, and Bob's your uncle. That's how I machine very accurate spindles in a large lathe without buying expensive collets. Let me give an example of how well this machines in this chuck. All right, so I have the spindle clamped in. I'm just going to do a quick example of how to do a taper with the setup that we've just done. I've just machined the end for the M2, and the rest will be a taper. And the length of the taper is actually very, very important. So we need to have a look at that, and we need to see how we're going to stop at a specific point. And I'll show you how to do that. So to start off with, everything has been zeroed. My taper slide is on 0. And what we do need to do is just find the end of the taper, and we want roughly 8 mils. So 7.58 is roughly there. Okay. We also want to zero the cross slide because that gives you a mark on where you want to stop. And then your cross slide stays on 0, and your 0 is going to be your end position. So let's cut this taper. Now we're cutting quite a slender taper, so you do need to be sort of light on your cuts. The first couple of cuts can just be rough cuts, but your last cut you want to do a nice sort of final cut. So my last cut is going to be 200 micron, and then it's going to be a very controlled feed, so we get that beautiful finish that you need to get these taper spindles to seal nicely. And you'll see I have finished, the taper is finished at exactly the mark that I made, so that's pretty good. One of my favorite methods of turning in a lathe is turning between centers. And if you offset the tailstock, you can machine incredibly accurate tapers. This is by far the best way to machine Morse tapers or any spindle for a machine. The best way to show this to you guys is actually with the finished example, because then you can see the difference between the taper and the center line of the lathe. And let me show you the complete setup. So it's very, very simple. It's just between centers. There's a simple dog clamp at the end, which is just 2 plates bolted together with 2 bolts. And what I do is I just V the center out. You can also drill 2 holes to catch it. And then instead of putting a center in your lathe, because not all lathe spindles have got sort of capacity to put in dead centers, you can just make one of these. And again, if you machine that in this chuck and you mark chuck number 1, when you put it back in the chuck, it'll always be in the correct position. And then all that you need is a catch for your dog, and your center will fit like that. The other side will be your tailstock. And there you go. Because you're machining on your tailstock side, or alternatively flip it around depending on which direction the taper is, you're putting on this side, you need to machine quite close to the ends, and then you don't get a lot of tool chatter. In this case, I machined close to the sort of tailstock. I haven't offset it because I want to show you how to offset it. But before I do that, one of the advantages of using this method is if you machine sort of a taper and the edge of the lathe or the tailstock moves in this direction, you'll see that corner moves away from your cutting tip, so it doesn't get into the way. That's one of the main benefits of machining like this. Any machining over here isn't in the way of your tooling, and your hand dials are far away, so they also don't get in the way. To set this up is actually very, very simple. And a lot of people battle with setting this up, but it's actually so simple. You don't even need a dial gauge because your length is so long. The offset is, in this case, the offset is 8.4 millimeters. So if you 0.1 millimeters out, it's actually not going to make that much difference on this taper. But if you a fraction out in a very short taper using a dial gauge, then it makes a big difference. But because it's so long, you're sort of multiplying or dividing your error because you can move it a lot further. So I've zeroed this. So this is in line with the headstock perfectly. And all we're going to do is we're going to offset this for this taper. Now this length, there's an equation to work out this length, and I'll give the equation right at the end. But all that you need to do is you have a slip gauge, and drill bits work incredibly well for slip gauges. This thing needs to work, move out 8.4, so I have an 8.4 millimeter drill, and I just put the drill in until it just touches, like so. You can see there it's got a nice touch on both sides, and then that is your position. This tailstock just needs to be moved till it just touches, and you will machine a perfect Morse taper at the end there. Now let's just have a look at that equation, because the equation that they give in some of the textbooks don't take into account the full length. They only give the equation for this part. And the equation is very simple. It works like this.
Sorry guys, I'm going to have to take you away from your happy spot behind the lathe. Let's just quickly have a look at the equation of machining between centers if you want to do a taper. And trust me, doing this equation is far better than iterating trial and error behind the machine. So the offset is just the offset to your tailstock from your center line. The large taper diameter is obviously the large taper diameter, and typically this is your 0 point. The small taper diameter is obviously the smaller taper diameter, and this is the side that you start machining from. Now, incidentally, the large and small taper can actually be anywhere on the taper. It doesn't matter where you choose those 2 points, as long as the taper length is between those 2 points. And then finally, the length between centers, and this is the part of the equation that they don't normally give, is just from one point to the other point. Now, I typically just use the length of the shaft because it doesn't really make that much difference if your center points go inside your sort of center hole, provided you don't sort of really go deep. It'll still be very accurate. Okay, but let's go back to my happy space in front of the lathe, and I'll show you a very cool example. It's actually this axle that I machined the other day, and it went a little like this.
And before we start cutting, let's just put a little bit of slippy slidey on that. Always a good idea. Good old slippy slidey juice or grease. And that's just normal automotive grease. So here we're going to make the shaft look, this is where we're going to make the shaft look really, really good. We're going to give it a bit of a taper, make it look cool. And this is how easy this is. So this is where we're going to stop. So touchy there. And we are going to cut a taper from that point. At the moment I'm just going to do a rough cut because I'm not too worried about the finish. Now this tool is actually meant to be cutting the other way, but this will be fine. So one of the things I do want to do is I want the left hand side of the shaft and the right hand side of the shaft to look exactly the same. So I do want to zero it in this direction so that both sides are the same. And one of the things you need to do when you're doing a shaft like this is you just need to check that it's not loosening up. Because that's bad. So you'll notice it looks a bit rough, and the only reason for that is I'm just cutting the wrong way. I'm not too worried about that. And in my design, the bearing surface where the actual wheel runs is quite a close fit to the size of that sort of necking of the end of the shaft. So I'm keeping an eye on that, and if I got my taper wrong, then I know that so this is going to be the final cut. I'm going to put it on 0. So it's 0 and 0. And this is my final cut on the taper. So you can actually see how much nicer this tool is cutting, because now it's actually cutting in the direction that it's happy to cut. And the reason why it wasn't cutting as happy in the opposite direction is because I sharpened it to cut as a left-hand tool, so it should cut from the right to the left, so sort of in the direction of the headstock. So when you flip that direction, you do look for trouble. And let's see how close. Oh, look at that. Check at that. So you'll see that I ended up exactly on the mark where I was aiming for. So that means that when I pulled the tailstock, I pulled it the exact right amount. And that surface just looks beautiful. So now all of my dials are set in 0. It's actually such an easy thing just to flip this around and do exactly the same thing, and it's going to look identical.